Let's start our class today by looking at some absolute value expressions, and we're going to evaluate them when we're given a replacement value for x. In this first one, we're going to replace x with a -5. We're then going to simplify to see what the expression is equal to. We'll have 4 times a -5 plus the absolute value of -3. So now 4 times -5 is -20. The absolute value of -3 is 3. We'll add these two together and we'll get a -17. When we're evaluating, we remember that absolute value is always positive. That's why the absolute value of -3 became 3. In the second example, we see two x's, so we're going to replace twice. 3 times -7 plus the absolute value of -7 plus 5. So now we'll multiply first. We'll get -21 plus the absolute value of -7 plus 5 is a -2. Well, the absolute value of -2 is 2. And since my signs are unlike, I'm going to get a -19. So evaluation just takes us back to expressions that we did in the previous chapter, but now we're adding in the element of absolute value. In our last class, we did some solving, and we solved by saying what values of x can make this a true statement. Well, we found out that we could replace x with a +7, or we could replace it with a -7, because both those statements are true. So x could be equal to 7, x could be equal to -7, and we did show this notation of the plus or -7. You can write it separately or as one. If there's only a variable inside of the absolute value symbol, then I know that y could be equal to 2 or y could be equal to -2. So when there's no operation, it's just the plus or minus of the number it's equal to. Let's see what happens if there is one or more operation inside of the symbol. In this case, it's a two-step. We're going to solve twice. We're going to take 3x minus 3 equals 9 and solve that. And then we're going to get 3x minus 3 equals to -9. Because remember, what fits in this symbol could either be a 9 or it could be -9. So solving twice, we'll add 3 to both sides. I get 3x is equal to 12. And then dividing, x is equal to 4. That's one possible solution, but there will be two. I'm going to add 3 again, and this time I get 3x is equal to -6. Divide by 3. X, it could also be equal to -2. By checking this, 3 times 4 is 12 minus 3. Absolute value of 9 is 9. 3 times -2 is -6. -6 minus 3 is -9. Absolute value of that is also 9. Again, when I see absolute value equations, it tells me to solve twice. Once the way it is, and once with the negative. Because remember, the value could be the plus or minus inside the symbol. These are two-step inverse operations. We will go ahead and add. I get 2y is equal to 12 and divide by 2. We're practicing our two-step equations by doing this as well. We'll now add 4 to the second possible solution here. That will give me -4 and divide by 2. Y is equal to -2 is my other possible solution. So again, the key to these is remembering to solve twice. Try this one. Remember, when you rewrite it the second time, you keep everything in the expression same. You just change what it's equal to the opposite. Go ahead and do one inverse operation first, which is in this case to subtract 1 on both sides. Second inverse operation is to divide. X could be equal to 7. 7 times 2 is 14 plus 1 is 15. Absolute value 15 is 15. Let's do the second side. I've got 2x is equal to negative 16. And I'll divide by 2, and I get x is equal to negative 8. Well, I'm not sure if that's right, so I'm going to check it. I'm going to have the absolute value of 2 times negative 8 plus 1. And let me see what that equals. Well, this is now negative 16 plus 1, absolute value. Absolute value of negative 15 is 15, and it works. Remember, we could have one step as well. Here's a couple one steps. Always remembering to solve twice, whether it's a one step or a two step. Subtract 4, and you get x is equal to 5. Solve again. X plus 4 equals negative 9. See what you get. This one is a multiplication, so I'm going to divide. I'm going to divide by 3. And I get x is equal to 5, and we have to solve twice. You complete the second one. We'll check in class. Last problem on this slide is a division. And we know that the inverse of division is to multiply. So multiply both sides by 3, and I get x is equal to 18. But don't stop there because you need to solve twice. In my second one, I have x divided by 3 is equal to negative 6. Solve again, and we'll check. Practice this this next one with 2 steps. And again, as long as you remember to solve it twice, you're in a good place. Watching your signs. One last thing I want to go over today is what happens when there is an operation outside of the absolute value symbol. We need to isolate that first. So anytime we see an absolute value equation and there's an addition of something, subtraction, multiplication, or division outside the symbol, we need to clear that first. So before I do anything here, I'm going to add 4 to both sides. That now leaves me with the absolute value of x plus 2 is equal to 14. Now I can go ahead and solve. I'll have the x plus 2 is equal to 14. And then I'll have x plus 2 equals negative 14. Continue to get your answer. Let's just see one more example. Again, I've got my operation outside of the absolute value symbol. So I'm going to start by adding 2 to both sides. Now I can go ahead and find the value of x because I'll have x minus 3 equals 11 and x minus 3 equals negative 11. And again, I'm leaving you to solve these, and you'll do some practice for your assignment today.